The cardiac cycle. This is the combination of the conduction system and the structure of the heart. So how is it that the impulse sent from the brain actually acts on the heart and moves blood through it and actually up to the lungs and around to the rest of the body? And it starts up here in our medulla oblongata, and it runs down either the sympathetic or the parasympathetic nervous systems. Sympathetic if we wanted to speed up, parasympathetic if we want to slow heart rate down. Now this impulse reaches two different nerves. The accelerator is located at the bottom of the sympathetic nervous system, and the vagus nerve is located at the bottom of the parasympathetic nerves. And what these two nerves do is act on the SA node, or the sinoatrial node. And when it does this, it either asks it to speed up its frequency or slow down the frequency of these myogenic impulses. Myogenic meaning it happens regardless of our control. So it happens regardless of our control. Now the SA node spreads an impulse across the two atria. Okay, so we have two sides of the heart, the right hand side and the left hand side, and both of these sides are working at the same time. Okay, so it's a dual pump. One side is putting it up towards the lungs, that's the pulmonary circuit, and the other side is sending it to the rest of the body, which is the systemic circuit. And this impulse spreads across the atria, causing them to contract. Okay, so the myocardium, or the heart muscle, the cardiac muscle, the myocardium is activated, it's stimulated, and this impulse causes them to contract. Now what happens here is known as atria systole. Okay, nice way to remember that is systole for all systems go. So it's currently working and the atria are contracting. Now this causes active blood flow to go from the atria down through the AV valves, okay, or the tricuspid on the right hand side of the heart and the bicuspid valve on the left hand side of the heart. This is forcing active blood flow down into the ventricles, and these start to fill up. At the same time, that impulse has now reached the AV node, or the atrioventricular node, and this, or the job here, is to cause a slight delay. Okay, it inhibits the impulse for a brief moment, and what that allows to happen is for ventricular diastole to finish, the valves or the AV valves to close up, and atria systole to completely finish. So atria have finished their contraction, blood has been actively forced down into the ventricles during ventricular diastole, and the valves snap up, closed. Okay? The AV node then sends this impulse down the bundle of His. Once it finishes going down the bundle of His, which is located in the septum, or the separating wall in the heart, the septum, it then reaches the Purkinje fibres, and the Purkinje fibres almost splay out into the myocardium surrounding the ventricles. In particular, the left-hand side of the heart, because that's got a far greater job because it's got to go around the whole body, whereas the right-hand side of the heart only has to pump blood back up through the pulmonary artery to the lungs. Okay, so that impulse has reached the AV node, there's a slight pause allowing ventricular diastole to finish. The impulse is then sent down the bundle of His and into the Purkinje fibres, stimulating the myocardium around the ventricles to contract. This is now ventricular systole, and blood is forced or ejected out through the aortic valve into the aorta to the rest of the body, or on the right hand side of the heart, it's ejected out of the pulmonary valve into the pulmonary artery and it's sent back up to the heart. So medulla oblongata, sympathetic or parasympathetic nervous system, acting on the accelerator or the vagus nerve. The SA node then changes the frequency that it sends impulses across the atria, causing atria systole. Blood is actively forced into the ventricles during ventricular diastole. The AV node pauses that impulse, allowing the valves to close. Ventricular diastole finishes, down the bundle of His into the Purkinje fibres, stimulating ventricular systole, and blood is ejected out of the aortic valve into the aorta, or is ejected out of the pulmonary valve into the pulmonary artery up to the lungs.